Good afternoon, and welcome to today's McGill News Webcast, The Magic of a Solar Eclipse. My name is Cassoff, Managing Director of Communications at McGill's Office of University Advancement. And despite what Mother Nature would have us believe, at least here in Quebec, it is Thursday, April 4th, 2024. Unless you've been living on the moon, wait, bad metaphor, even if you've been living on the moon, you are surely aware that next Monday, April 8th, many North Americans, including those of us here in Montreal, will experience a total solar eclipse, one of the rarest and most fascinating celestial events of our lifetimes. To mark the occasion, communities all along the diagonal path of totality will be organizing viewing parties to celebrate this moment. McGill is no exception, with hundreds expected to gather on the lawns of our downtown and McDonald campuses, and at the Galt Nature Reserve in Mont-Saint-Hilaire. Why is the public so fascinated by solar eclipses? How unique are they? And what do you need to know to stay safe and make the most out of this once-in-a-lifetime event? Joining me today to answer these questions and many more are two members of the McGill community who know their way around telescopes, fast radio bursts, and complex astronomy charts. Let me introduce them. First, we have Professor Nicolas Cowan, who's an associate professor in McGill's Departments of Physics and Earth and Planetary Sciences, the Canada Research Chair in Planetary Climate, and a member of the Trottier Space Institute at McGill. And Andrew Fazekas, also known as the Night Sky Guy, is a science writer, broadcaster, and lecturer, a regular contributor to National Geographic, and past president of the Montreal chapter of the Royal Astronomical Society of Canada. He holds 2 degrees from McGill, including a master's degree in wildlife biology. Thank you both for joining me today. We were supposed to be joined as well by Tracy Webb, another faculty member at McGill's Trottier Space Institute, but she had to send along her regrets at the last minute. So, gentlemen, the show is in your hands. And just before we get started, a note that if you are watching us live and you have a question for our star-studded panel, you can email us at aoc@mcgill.ca, and I'll do my best to address them to our guests. So let's get started. Before we jump into questions about next Monday's eclipse, I'm curious to find out a bit more about each of our panelists and what spawned their fascination with outer space. Professor Cowan, maybe I'll start with you. Can you tell us a bit about your interest in space and what sorts of questions you're exploring through your research at McGill?
Sure. So I guess I was interested in space in high school. Like a lot of people, I wanted to be an astronaut. I followed all the space news. I still have old newspaper clippings from back then. Then when I went to university, I studied physics, and at the time, McGill didn't actually have any astronomers, and so I kind of came out of my undergrad degree not really wanting to do physics, but wanting to do something physics adjacent. And that's when I learned that there were actually professional astronomers. So I could study space. You know, it's not quite as good as being an astronaut, but I could at least study space for a living, which was pretty fun. And so, yeah, so that's how I ended up in astronomy. And the timing worked out really well. I started my PhD right when we started getting the first photons from exoplanets. So basically, we started detecting light from planets orbiting other stars. And so the timing was just great. Like I basically started my PhD, and that's what I've been studying ever since, is studying those planets and studying the climates of those planets that are orbiting, hundreds of light years away. So it's been a lot of fun since then.
Wow, I see Andrew nodding along. He's really excited about that. So maybe I'll turn to you, Andrew. I'm just curious. I mean, I mentioned in the opening you're a wildlife biologist by training, and you have 2 degrees from McGill's McDonald campus, which is known more for its land-based fields like agriculture and food science and natural resource management. And yet you've dedicated your life to observing the mysteries of deep space and bringing this knowledge to the general public. So I'm curious, how did you fall into this line of work, and why are you so keen to share this passion with amateurs like us?
Well, that's the key word. It's passion. And so I have this crazy passion for space astronomy. It's something that's been in my life since some of the earliest memories I had is sitting on my dad's lap. We lived in Côte Saint-Luc downtown in an apartment building. This is in the early 70s. He bought a little dinky little telescope. I think it was from Pascal's way back when. Some of your listeners may remember that. Pascal, and we went to the rooftop of our apartment building, and he showed me the moon up close. He showed me the moons of Jupiter, the rings of Saturn. I was hooked, and I would go to my school's library and just get as many books as I can. And space just was something just caught my imagination naturally. And I was very thankful that my father was there to spark that stuff. And of course, it ended up in science fiction with Star Trek, being really interested in that, what the possibility is of things outer space, humanity's expansion into the universe. So all of this was just great fodder for me. And then pivotal was, of course, Carl Sagan's Cosmos in 1980 on PBS. That series completely blew my mind. I was, I think, 10 or 11 at that a year old that time. And then I knew that astronomy was going to be part of my life. Now, I did a diversion because I had the opportunity. I loved wildlife as well, and I had the opportunity and I was really good at biology and chemistry. Those were things that I just excelled at. Physics wasn't my forte. That was something and math wasn't my forte either. But biology I just loved, and animals I loved. So I decided to become a wildlife biologist, and naturally, of course, McGill and McDonald campus was the place to be. I'm a West Islander all my life. And then so that was the place to go. And I had the very good opportunity to work in Africa, in the Kalahari Desert. And I actually did my graduate work on antelopes, African antelopes, looking at their endocrinology, the stress hormones. As a lot of these animals are in the wild, in the desert. And I literally was able to see the most magnificent skies that I ever encountered in my life. There's no light pollution in deserts. In the Kalahari, it's just everything is there. And that rekindled my interest of space. I knew that was something that I'm still interested in. So with a lot of different diversions, what I came to realization about myself is that I cannot let go of space and astronomy. I have to continue in it. And I said I cannot just. I guess I'm not like Nicolas here, where I could just focus on one thing. I wanted the entire universe. I just couldn't get enough of everything. So I said, I think what I'd love to do is share that passion with people. So I became a communicator, a science communicator. And I've been doing that for over 25 years. I've never looked back. I've had the good fortune of writing books. I've had an amazing fortune of working with astronauts, working with scientists like Nicolas, and getting a sneak peek at some of the most amazing, frontline work and how we're learning about the universe, what makes it tick. It just doesn't get any better, and I'm still want to learn more.
Well, we're definitely going to put your space communication skills to the test in the next 45 minutes or so. So, so hang on. So we're just 4 days away now from this big moment everyone's been talking about, the total solar eclipse that's going to carve a diagonal path across the skies of North America from Mazatlan, Mexico to the eastern shores of Newfoundland, unless you watch CNN, and I think it stops in Rochester, New York. So, Professor Cowan, let me turn back to you. So how long have you had this day circled on your calendar, and how does this moment stack up with other celestial events that you've witnessed in your lifetime?
Yeah, so I guess I've had this on my calendar since I saw my first total solar eclipse in 2017. I'll be completely frank, as a professional astronomer, I don't know. I guess I didn't really think much about eclipses and stuff like that. I'd seen some lunar eclipses before when the moon passes in the Earth's shadow, and they're cool, especially if you have a telescope to look at them. I think I'd even seen like a partial eclipse before, like with a pinhole camera, and you could see like a bite taken out of the sun. And I'd seen some things like that. They're really cool if you're a nerd, which I was. But then I went to an astronomy meeting in Idaho, and it was timed with a total solar eclipse. And I saw the total solar eclipse, and it blew my mind. I was like, whoa, this is a totally like next level experience. I've seen the Aurora Borealis. This is cooler than that. This is like really a mind-blowing experience to see the solar corona, to see stars during the day. It's just amazing. So basically, when I saw that eclipse in 2017, I was like, this is amazing. I need to do this again. And that's when I learned that, oh, actually, I live in Montreal, and there's going to be an eclipse in a few years passing through Montreal, which is very fortunate. So yeah, I would say since about 2017 is when I've had this on my calendar.
Wow. So, Andrew, let me ask you, are you surprised by how this event seems to have captivated the attention and the imagination of the public in the way it has? And what is it about this eclipse that you think has everybody so excited?
Yeah, I guess the magnitude of the awareness is really amazing. It's dumbfounding. It's the coverage, the media coverage is incredible. This solar eclipse, this total eclipse, is going to go down, I think, in history as the most watched ever in history. It is simply because, we're living in the 21st century and we have this amazing internet thing going on that allows to connect with people around the world. So even if you're not in the path of totality, or not even on the continent of North America, you're on the wrong side of the earth, you can still virtually be connected live through, and there's multiple live streams, crazy amounts that are popping out. The technology is in everyday people's hands to share the experience. Now, with that said, it's nothing like actually seeing it in person. And what the other aspect that's really, I think, amazing is that the path of totality, as you had mentioned, Derek, going through, the southwest into the northeast part of the continent, is going through very highly populated regions. So, unlike anything, there are literally tens of millions of people living in the path of totality, which basically means you could just step out of your doorstep and look up and see this wondrous celestial event. And on top of that, there's at least 10 million people estimated to be traveling into the path of totality, not just from the continent. I know people coming from halfway around the world just to see this event. So it's wondrous to see all this interest. As a person who loves to communicate astronomy and the wonders of the universe, this is a bonanza. This is going to raise awareness unlike anything else about the beauty of the night sky and the daytime sky in this case.
Yeah. So
So just to follow up
go
on
ahead.
that, I mean, I saw a map this morning of Airbnb bookings, and it's hilarious for this coming weekend. And you can just map out; it's 100% booked. The entire path of totality is booked. And I will say, adding on what Andrew's saying, that the fact that you can get eclipse glasses very easily is a big difference from like previous eclipses, in the 70s, for example, when people didn't really know what to do. And essentially it was like, either build a pinhole camera or you're just told to like hide in the basement because it's dangerous to look at the eclipse. So I think like the technology has improved and it's made it a lot more accessible now.
Exactly. And you know what I'll add to this is if you look at the big picture, what I've noticed as an astronomy communicator is there is an awareness of astronomy, of sky watching, unlike anything I've ever experienced in over the 50 years that I'm alive. And it's a big thanks to the digital technology, is just being what's available and getting people to understand some of these amazing celestial events. So this all put together means that this is just like a rock concert that's going to be happening on Monday.
Wow. So let me ask, I'll turn to you, Nick, for this. I mean, maybe you can explain a little bit of what exactly physically is going to be happening on Monday during the sort of, throughout this path of totality. So, I mean, my sort of knowledge of astronomy is that the sun is much larger than the moon. I think it's 400 times as large. So can you explain the physics of what's going to happen between the sun, the moon, and the earth to create this really unique moment?
Yeah, sure. So, I mean, the key, well, there's a couple of keys. One of the keys is that the moon is closer to us than the sun. So just like, my thumb is smaller than the sun, but I can perfectly block out the sun with my thumb pretty easily. But even in its orbit around us, the moon is sometimes closer to us and sometimes farther. When the moon is a little bit farther away from us, it actually can't give us a total solar eclipse. We only get a partial or an annular eclipse. So the key for the total solar eclipse is the moon has to be a little bit closer to us than it usually is. And then the moon, basically the orbit of the moon and the orbit of the Earth around the sun have to be perfectly lined up, which only happens twice per year. So you have these two sort of eclipse seasons per year. Nowadays, one of them is in spring, one's in the fall. And that's where all the eclipses occur. Your lunar eclipses and your solar eclipses all occur during this eclipse season, but most of them, usually they're like near misses, they're like an almost partial eclipse, or like a sort of a penumbral lunar eclipse. And they're things that, again, if you're like a real astronomy nerd or an amateur astronomer or something, you get excited about it. Your average person really doesn't care. So a total solar eclipse is quite rare. And then having a total solar eclipse that actually passes through populated regions is just like super awesome and sort of unprecedented in the modern era.
Wow. So Andrew, maybe you could, again, I don't want to, maybe I should warn you, this is spoiler alert, what's going to happen on Monday. But for those of us who are lucky to be in the path, like those of us here in Montreal right now, can you walk us through like what's actually going to happen that afternoon? Like how long does this eclipse last? And what are the various stages people will see and experience if you're out for a couple of hours on a lawn somewhere?
Yeah, so just to give a broad a picture of what we're thinking. So this is happening all in the mid-afternoon period. It's starting not too it's around 2:15, 2:18 after in PM. There's about a 3 hour window of the eclipse unfolding. So from the beginning is really where the first contact happens of the moon's silhouette reaching the edge, the limb of the sun, and you can and then slowly that moon silhouette slowly creeps across the surface of the sun, the disk of the sun, and what it will look like to sky watchers is an ever increasing larger bite being taken out of the sun. And it'll eventually the sun will look like a crescent shaped, similar, reminiscent of what the moon goes through in its phases. So but it'll all unfold in a matter of an hour and a half. So that crescent shape will become more extreme, thinner and thinner, the sun, as that moon glides over it. And then there'll be a point where it's almost entirely covered, and that is when you get some really interesting effects come. So there'll be environmental effects. When it's something like 97, 98%, I think, covered, you start beginning to see that it's starting to look a little bit darker, maybe perhaps. If you're a very keen observer in your environment, you'll notice that the skies are starting to a little bit dim a little bit. And then in the few moments before the actual totality begins. What we call totality is when the entire disk of the sun is covered by the moon. There's a precious few months where we have something called Bailey's beads and the diamond ring effect. And this is really fascinating because what this is there'll be looks like little bursts of dots of light of the sun, sunbeams that are going along the edge of the silhouette of the moon. And what that is caused by, and this is what I think just blows my mind, is that it's the uneven terrain of the moon. So it's the valleys and mountains of the moon. It's not smooth, right? We've seen pictures of the moon close up from Apollo and all that. There's mountains and valleys. And the beam of sunshine that's coming from behind it, those solar rays, are poking through those valleys and the uneven terrain. And that's what's causing these, what are called Bailey's beads and the diamond ring effect. And then, boom, the entire disk of the moon covers the sun, and we get what's called totality. Now, that moment of total coverage of the sun is when the skies do darken to like twilight level, like as you'd experience after sunset, twilight time. And that's where all these cool environmental effects, like crickets could start chirping if you're south of here, obviously. Certain birds start chirping that come out at sunset. All of that, stars do become visible. And that can last anywhere from like 30 seconds, perhaps, to maybe up to 3.5, 4 minutes even, depending on how deep you are in the path of totality, how close you are to the center line of that totality. For us here in Montreal, we are just on the edge. We're skirting the edge of totality. So it's pretty short, that those moments of darkness. We're talking around 30 seconds to a minute, depending on where you are. The more south you are, closer to like Plattsburgh. Plattsburgh is almost on the center line there, south of us. They are going to experience more closer, I think, over like well over 3 minutes, 3.5 minutes, maybe even more from that point. So it really depends on where you are. And that after those few precious moments, the reverse a sequence starts happening as the moon comes off of the surface of the sun. So it's another hour and a half until it ends completely.
Wow. So that sounds wonderful and exciting. I can't wait. Nick, I see you're wearing a toque for this webcast. Let me ask you, during the eclipse itself, is it going to get cold? Like, will temperatures drop like they would gradually as we hit the nighttime, just more suddenly?
Yeah. So it'll definitely get cooler. I mean, my experience, the only time I've been in the path of totality, like I said before, was in a high altitude desert in Sun Valley, Idaho. So there it actually got quite chilly pretty fast, and you had to put on like a puffy jacket. Around Montreal, I expect it will get cooler, and you might want to bring an extra layer. I honestly don't know the prediction of like how many degrees cooler it'll get, but I think, yeah, it'd be comparable, because it takes place over the course of a few hours. It's good to just wear layers in general. I mean, this is what you do when you go in the outdoors. So bring a jacket, bring a toque, that kind of thing. Also, bring lawn chairs. There's like all sorts of general advice, because you're basically picnicking out there, right? You're like hanging out with, depending where you are, either with a few friends or on your back deck, or with hundreds or thousands of people if you come to the McGill campus, for example. And it's good to just like set yourself up with a comfy situation so that you can take a break and not have to be standing for 3 hours.
Wow. I mean, it's April, so I mean, I haven't worn a winter coat, had mittens since like I left the house 3 hours ago. So, anyway, um, and Andrea, just to follow up, you talked about sort of the path of totality. For those in North America who are not directly in the path of totality, will they still experience any elements of the eclipse?
Oh, definitely. So the farther we've all seen these maps where you have that path. I think it's about, Nicolas, what is it? It's like 200 kilometers, 250 or something like
Yeah,
that
something like that,
wide. Yeah. So if you're inside that width of 200 whatever kilometer pathway, all that stretches from Texas, right, all the way through here, you'll see totality. So you see the entire 3 hours, all the sequences. If you're on either side of it, you will only see a partial eclipse. So it means like, like folks in Toronto, for instance, are literally on the edge, just outside of the path of totality, and they will see, almost like 99% of the sun disappear, something like that, really close, but not quite there. So the skies don't darken completely as they would in totality, but they will see the entire sequence. And the farther west you go of the path of totality, or the farther east you go on either side, the less of the sun will be covered by the moon, but you'll still see some. So the entire continent is going to be, seeing a partial eclipse at least.
Mm-hmm. So I guess we should talk about the weather, and I don't mean the blizzard outside my window right now, but the weather next week on Monday. And the good news, at least for those of us here in Montreal, according to the long-range forecast, if you can believe it, it looks like Monday will be a beautiful day, clear skies, maybe not snow on the ground, but definitely a clear day. So I guess my question to you, Nick, is do you need clear skies to enjoy the eclipse? And what can people expect if they happen to be in an area with cloudy skies or rain in the forecast?
Yeah, so a clear sky is the best, because then you get to kind of enjoy all the aspects of the eclipse, including things like seeing stars during the day, seeing the solar corona, Bailey's beads, and all these kinds of like really neat things. If you're in a place that's partially cloudy, if they're like thin clouds, then it's kind of a double-edged sword. Then you won't get to see the corona; it'll be too faint to see. But the upshot is that if there's clouds in the way, it's a lot easier to look at the sun and get some like cool photos of like a bite taken out of the sun. And so if you look through like the internet and look at pictures of partial eclipses, most of the nice ones you'll see from amateur photographers or professional photographers are through clouds, actually. But so that's all right. If it's extremely overcast, if it's just like a rainy day, then it'll just be weird that it'll get pitch black in the middle of the day for a while. And this is something to pay attention to if you're in an urban setting. The lights around you, some of them are on timers, and so they'll stay off. Some of them are on like have a little photo detector, and those might turn on. So just be aware. That would suck because it would blow out your night vision, right? Because what you want to see, the stars and the solar corona during an eclipse, is you want your pupils to be like really, really big. It's actually one of the reasons that the eclipse glasses are so handy, is that they block out so much light, your pupils dilate, and it allows you to safely look at the crescent sun without burning your retina. But then it means that once you hit totality, and it's actually, you can't see anything with the eclipse glasses, you pull them off and your pupils are really dilated, and then you can immediately see all sorts of other cool things. So yeah, but the point is, like, if it's like raining where you are, you're not going to see any of that. You're not even going to see the sun, and it's just going to be like raining, and then you'll be like, okay, it just got dark for a few minutes, and then the sun will come back up, and it'll be just a gray, rainy day again. So like, definitely not as much fun. So like, I think if you're able to relocate, around where we are, it's not like we're in the mountains where there's like, typically the weather patterns are fairly large on the scale of like the city and stuff. So really, I'm not sure you could like chase holes in the clouds exactly, but I will say it is worth moving a little bit into the path of totality. Like if you're outside the path of totality, please consider relocating a little bit, like get on a bus, drive, walk, whatever, because it does make like a big difference, right? Because a partial eclipse is cool, but like partial eclipses are way more common than totality. And so really take advantage of the fact that you can see totality if it's a sunny day. If it's a gray day, then whatever. It's like, just go watch a Netflix movie or something. But like, but if it's like a beautiful sunny day, then it's really worth it to see totality.
Right. Wow. So I'm glad you mentioned protective eyewear, and thanks, courtesy of the Trottier Space Institute and the Trottier Foundation, I managed to pick up my set last week. I can't see anything now, so I'll take them off. So maybe I'll ask you, Andrew. Well, first of all, so I know there's a lot of discussion around eye safety. In fact, here in Montreal, I know most grade schools and high schools have actually suspended classes for next Monday to reduce the risk of eye damage to their pupils. Sorry, I couldn't resist that pun. But on a serious note, what do we need to know about the dangers of solar eclipses?
Yeah, so I mean, first off, when they say never look at the eclipse, a partial eclipse with unaided eye or without proper solar filters, you just don't look at the sun any old time, anytime. It doesn't just apply for eclipses, but because if you stare at the sun, I guess the only aspect here is that because of everyone is so excited about it, they might have the tendency to stare at the sun, trying to really look at what's going on with this eclipse. And then the fact that you're staring for a length of time, it increases the chance of damaging your retina, basically. And the longer you do that, the larger it's may not even be temporary. It may be a permanent blindness. You can get a blind spot basically appear in your vision, and that'd be a shame, right? So we have to protect our eyes at all costs, and it can't be any easier than just making sure that you have access to these glasses. Now, what makes these eclipse glasses special is that there's a special film that's placed inside in the viewers, and it looks sort of like an aluminum foil. It's called Mylar, this film, and it basically blocks out 99.99998% of the solar rays. So it leaves just enough light from that you can see the sun, but you pretty much can't see anything else. I mean, that's one way to test these glasses, by the way, for safety reasons at home, is you put them on at home. And if you can't see anything inside, okay, you've tested inside. Maybe if you go to a really strong light bulb and you look at it, you might see very faintly there, but that's about it. Then you test it outside. You shouldn't be able to see anything else except the sun through this. And with this, you could see the entire part. And this is something I want to point out, is that through the entire 1.5 hour of partial eclipse, right, as the sun becomes more and more hidden, you need these glasses. But the moment that the sun is completely covered, we call totality, we reach totality, that's when you should take off your glasses, because that's the only way you're really going to see anything. You won't see the sun anymore through the glasses. You take them off and you'll see that beautiful image of the eclipsed sun, which will last, a few minutes, a precious few minutes. And then once there's the first hint of the sun coming back, boom, you put the glasses back on, and then you watch the rest of the show of the partial phase with the glasses. So it's very important to have these if you want directly viewing it, with it. Now, there are indirect methods that are very safe. There's something called the projection method, and that's really easy. What you do is you just punch a hole in a piece of cardboard, and you have a second piece of cardboard, and you basically allow the sunlight to go through one piece of cardboard and get projected on the second piece. And you'll see a beautiful little miniature image of the sun as it's being gobbled up by the moon silhouette. Another really cool thing you can take a colander from your kitchen, with the holes that you usually sieve out, your pasta with. All those little holes will project. If you put it in front of you and project it onto the ground, you can project a whole bunch of little miniature images of the eclipse, of the partial eclipse sun. It's really a fun little experiment to do with kids.
So yeah, just to add on what Andrew was saying, the keys to wear the glasses when you're looking at the sun. I mean, this event is going to take hours. So during the partial eclipse, like if you're having a conversation or having a beer with someone next to you, you can take the eclipse glasses off. Just like in normal life, like when we stand around, the sun is always there and we're not like freaked out about it, right? The sun is no more dangerous during an eclipse than it is at normal times. So it's just when you want to look at the sun, right? It's kind of obvious. Like you put on the eclipse glasses. Don't be like the former president of the U.S. who kind of is like, I'm just going to squint at the sun. And like that's, I mean, honestly, those are the demographics of people. If you look at the 2017 eclipse that went through the U.S., millions and millions of people looked at it, and the demographics of the people who did get eye injury, none of which were permanent, but the people who did get the eye injury were basically men in their kind of 20s and 30s and 40s who were kind of stubborn and were like, no, it's all right, I don't need those eclipse glasses. And they're just like, I'm going to stare at the sun. And so the one thing I will say, the one time where it's a little bit more subtle than that is in the very late stages of the eclipse, because at that point, most of the light is blocked. And the problem is that our bodily reflexes will not kick in. So at the very late stages of the eclipse, if you were to look at it naked eye, your body wouldn't make you turn your head away and your eyes wouldn't water in the way that they normally do if you look at the sun. That's when you really have to remember to be wearing your eclipse glasses, right? So just anytime you want to look at the sun, wear the eclipse glasses.
That's a really good point, Nicolas.
Totality, right? Like when it's the total solar eclipse, then you take off the eclipse glasses because otherwise you can't see anything. But basically, as long as you can see something through the eclipse glasses, it means some of the sun is visible. Because as Andrew said, the only thing that makes it through the eclipse glasses is the sun. So if you see something with the eclipse glasses, keep them on. And then if you don't see anything, that means it's time to take them off and enjoy the view of the corona. That's basically it. That's
a great point. Yeah. If you don't see anything of the sun anymore, that's the point you can take your glasses off. And I think what you mentioned also, Nick, was very interesting. I've also read that at the very late stages, as you were mentioning about the eclipse, as it's just in the few minutes before totality, like you were saying, that our reaction doesn't kick in to look away. Also, I read that our pupils would be opening up wider because the skies are darkening, right? So it's this natural reflex that's in the eye to open up your eyes wider to let more light in as the skies are darkening, but yet there's still sunshine. So it opens it up to possible damage to your eye because of that opening that's happening with your eyes.
Right. Okay. Wow. Wonderful. So again, if we have I'm going to turn in a minute to some questions that have come in from our alumni. We've received a fair number of them. I'll try to get to as many as I can. If you have a question for either Andrew or Nick, you can email us at aoc@mcgill.ca. Before we do that, I just want to ask you one more question, Nick. It's not every day I get to, have a conversation with an astrophysicist. So I wanted to ask about research. So I know your research is not directly involved or implicated in eclipses, but can you talk about maybe what scientists have learned from past years during eclipses? For instance, I heard that one of Einstein's big theories, I think the theory of relativity, was actually proven correct during a solar eclipse. I mean, do we have examples of research taking advantage of solar eclipses?
Yeah. So, I mean, for starters, I actually do use eclipses in my everyday life, but not eclipses of the sun. I watch planets pass in front and behind their star. So those are partial and total eclipses of planets and stars. But yeah, so the solar eclipses, like what we're going to get to witness on Monday, Those have been used to do some really interesting science. So if you go back a century, the smart fellow named Einstein had come up with a general theory of relativity. This is like a new way to think about gravity. One of the predictions was that light was going to be bent. There was a previous prediction that light might be bent, but Einstein's theory differed by a factor of 2. So he basically said the light would be bent twice as much. And so then some astronomers wanted to test this out. They said the way we can tell if light is being bent is we need a really massive object. The nearest massive object is the sun. It's very massive. But they needed to look at stars whose light was passing close to the sun. Now, of course, that doesn't work because most of the time when the sun is up, the stars are not, because you can't see the stars because the sky's too bright. The only time you can see stars where their light is passing close to the mass of the sun is during a total solar eclipse. So astronomers knew this, and they basically proceeded to set up these campaigns to try and watch total solar eclipses and carefully measure the positions of stars. And they kept getting like clouded out. So it literally took years to eventually get good weather. And they did this in multiple locations, and they actually managed to measure the exact positions of these stars. And then they re-observed those same stars 6 months later when they could just look at them at night the way we normally look at stars. And indeed, the positions of the stars had changed, and they changed by exactly the amount that Einstein had predicted. And so this was like a huge deal because it basically meant that, you know, our old school understanding of gravity, which was like Newtonian mechanics, was not quite right. And this new general relativistic framework with space-time and all the weirdness, it turns out that was correct. So it was big news. It was like front page of the New York Times, above the fold. That's kind of the last like major scientific discovery that's come out of a total solar eclipse.
Wow. And for our younger audience who's wondering, like, what's a newspaper fold? That's another conversation. Andrew, are you aware of any projects underway this week coming up that you know, scientific experiments that are sort of relying on the eclipse?
Well, it's interesting because one of the ones that are really capturing imaginations, I think, is more earthly in its nature and looking at environmental effects. So, you know, again, with the digital age that we live in, we can do what's called citizen science, where the average person can participate, help professional scientists get some answers to some questions. And one of them that they're looking at is, how does wildlife react during a solar eclipse? Is there behavioral changes, temporary behavior changes that occur? And what's interesting is this idea of, you know, nocturnal animals coming out during those moments of totality. So there are apps, smartphone apps out there that are being designed to listen using the microphone on board the smartphone to listen to what's happening around them. People logging the temperature drops locally. How is there any differences if you're on that path? How close you are to the center line? Does that impact the depth of totality? Does that impact the level of temperature drops? So it's really interesting to see what kind they're looking at, the environmental effects that never, you know, there's been a lot of, just discussions about it, like, on Reddit and places like that, but there's never really been anything studied. And now we can unleash basically millions of people with their smartphones in hand to do bona fide science, to answer some questions of, are there any differences in our local environments during an eclipse?
Wow, sounds fascinating.
Just to pick up on that, one pro tip is, if you have some sort of cell phone app that you're using during the eclipse, just make sure you're not looking at the screen, because you're going to blow your night vision. Like if you're wondering, like, oh, totality should be any moment now, let me look at my phone, and your pupils are going to get really small, and then your friends will be like, oh, it's totality, I can see the corona, and you look up, what? I don't see anything, because you've just screwed your night vision, right? There's a reason that astronomers at astronomical observatories, like, we have all these very, very dim red lights, is because that doesn't screw your night vision as much as the blue light. It's the same reason why you're not supposed to look at your cell phone before going to sleep, right? Like that, the kind of blue LED light from cell phones is really the worst for night vision. So just like, as much as possible, don't look at your screen during the darkest moments of the eclipse. Like, A, it'll piss off anyone near you. It's sort of like the movie theater, right? And B, it's really going to ruin your experience. So like if you have these cell phone things, like turn them on and put the screen down and just enjoy the show.
Wow. So that's a very good advice, and I wonder how many will actually heed that. So let me turn to some questions from our alumni. We have about 15 minutes left. We got a ton of questions have come in, so I'll try to get through. Maybe we can go through them quickly and get some short answers, I suppose. If you have any questions you haven't sent in yet, it's aoc@mcgill.ca. First one I'll get to comes from Mary Fair. She's asking, is it safe to watch the eclipse directly from indoors? In other words, does the glass in windows offer enough protection from solar rays?
No,
Okay.
don't do it.
Yeah, that's right. It makes no difference. Yeah, exactly.
All right. Second question's from Melody Sims. She's asking whether post-eye surgery glasses can be used safely to view the eclipse, and is there a place where she can test the glasses for safety before the event?
I don't think so. I mean, unless those, again, I mean, I think the test that Andrew described is pretty good. Like if the glasses have to be so dark that you can't see anything, even a really bright light, all you can see is the sun. And I can't imagine anyone giving you those even post eye surgery. But I'm not like a ophthalmologist or whatever. But I don't know. I personally wouldn't risk it. I would just use like Eclipse glasses. And if you don't have a pair yet, it's probably late to order them, but you can show up on McGill campus and get a free pair on Monday.
Okay, good. I'm glad you asked that because we just got another question that's come in specifically about that. So this one came in from Nadia Roy. She actually had two questions. So she's saying, it says that the glasses are available at McGill. Are you sure to have them, or can there be a shortage the day of?
I feel like I've heard that we have a lot, like some number like 10,000 of them or something just completely bonkers.
Astronomical.
Yeah, it's an astronomical number. So I think, again, if you've already got your eclipse glasses, then don't come and try and get more eclipse glasses. Don't hoard these things. They're utterly useless except for during an eclipse, right? But if you're kind of stuck and you don't get your Amazon delivery or whatever doesn't come through on time and you're downtown, then by all means come to the Roddick Gates and come try and pick up a pair of eclipse glasses and look at the sun with a bunch of other people.
Right. And we've received a few questions about where do I get my glasses. So definitely McGill, and I guess McDonald campus would be a similar setup for those in the West Island. Nadia had a second question, which was interesting. She's asking, what do you recommend for 3-year-old children? Would it be safe for them if they are supervised by an adult at all times?
Totally. Just they got to keep the glasses on. This is the thing. And that's one where it's useful to have with kids, you might want them to actually keep the eclipse glasses on kind of all the time and not have this thing of like they can take them off to like have a sip of beer. They probably shouldn't be drinking beer either at that age. But like they should probably just keep them on the whole time and then have like a responsible adult say, okay, take your glasses off because it's totality. I don't know. That's what I would do. I mean, my son is the child of 2 astronomers, so he's witnessed a lot of these astronomical events, and he's pretty responsible. We just make it clear like which things are dangerous and which things are not dangerous, and he's not, he doesn't want to blind himself. But at 3
don't forget.
yeah.
Yeah, don't forget. I mean, it's a 3-hour event, right? So if you're talking about little children, they're not going to have the attention spans to, concentrate and care about it. I'll be honest, it'll be just moments of watching it. And I think it's up to the adult to really say, okay, now take a look. There'll be some, because it's more likely the kids will be doing something else, and you'll just want to bring them in to say, okay, there's another phase that's of the event that's worthy of looking at it. And that's with the adult supervisor. So it's really up to the adult to, I think, really guide the children and going and knowing that, you want the partial phase, look, there's a little bit of sun that's out. And then check back maybe a half hour later, again, look at the sun. You see the difference? And it's a great educational teaching moment, that you can, a parent and a child could have together and explaining things. And as a parent, if you're not sure about what's going on, it's a great moment to learn together. Don't be afraid as a parent to say, I don't know. Let's investigate what's happening. And the beauty of the internet, you can also look that up quickly of what's going on. And it really engages the kids. It's a great bonding moment too.
Wow. Okay, great. So we've got a couple of questions that have come in now about photography. So before we went on air, we got a question from C. Lanil, who was asking, what precautions should I take, if any, to make sure I don't damage the lens on my iPhone if I try to photograph the eclipse. And we've just received the second question now from Roseanne Tom, who's asking about how can she prepare to photograph the eclipse from phones and cameras? What's the easiest, safest way to do it?
Use one of these glasses, one of the frames, and put the frames over your camera lens on your smartphone. That is the quickest, dirtiest way to do it. I mean, they make these separate ones that clip on, and you could do that so that it clips on and stays on it. But that's really the simplest way of done. I've used that, in a pinch to do it in 2017. I did that, and you get very pleasing shots. I think what Nicolas was mentioning about a little bit of a layer of a cloud, if there is, that's a natural filter that comes in front of you, and you can safely take a picture. It's really when the sun is almost uneclipsed and really wide. You don't want to burn out the CCD chip, the sensor on in your phone. You don't want to burn that out with a strong, having the phone kind of, looking at the sun for a very extended time. So you have these tricks that you can use, but definitely, and try to do photographs where you frame the foreground into your photographs. Looking at an orange little circle can only go so interesting if it's black around you. With these, you only see an orange circle, right? So with a bite out of it, to make it more fascinating, I think, is to take wide angle shots. So you have like the ground around you, buildings and things like that. It'll make the photograph much more appealing, and it makes a great memento.
Great. Okay, so we've got a bunch more. Let me go through this. So a question from Andrea. I guess you mentioned earlier, Nick, about the corona of the sun. So she's asking if during totality we don't see the sun, what is the corona? And maybe don't answer with beer this time.
So the corona is basically the plasma outer layers of the sun. So the sun is a ball of plasma, but the outer layers of it are very wispy. Like they don't emit enough light for us to see them normally. They're very faint. They're comparable to like sometimes when you see the moon at night, not like a full moon, but like a crescent moon or something like that, like in terms of the amount of light it gives off. It's kind of like that. And they're enormous. Like they look like giant flames. They're not actually fire. It's like it's a plasma that's magnetically entangled, but it looks to the human eye like flames, and it's much larger than the sun. So it's extremely striking to see. And yeah, it's something that you can only, with your human eyes, you can only see it during a total solar eclipse. Obviously, astronomers have widgets called coronagraphs to study this all the time. But as like a mere mortal, you can only see this during a total solar eclipse, and it's super cool.
All right, so we have 5 more minutes, so let me jump through a few more. This one, I know we talked about animals briefly here and there. Maybe I'll turn to you, Andrew. Question from Caroline Aubin. She wants to know if animals are aware of and react to eclipses.
Well, this is the big questions, right? And what species are they, that do it? And so I think a lot of wildlife biologists are coming into this, looking at trying to answer these questions. Definitely, there are a lot of stories of bird species that are nocturnal, that just start behaving as if nighttime has just set in, as the darkness sets in for those precious few minutes. Even insects come out. I remember I was on the beach in just north of Charleston, South Carolina in 2017 for the eclipse, and when totality hit, we actually started getting like mosquitoes come out, which we didn't have in total sunshine. We usually, mosquitoes just don't like to be exposed. But as soon as that darkness, we started noticing there were mosquitoes. It was very noticeable effect on us. But it only lasted those precious few moments. And then when the sun returned, those bugs were gone. So there are a lot of wildlife. And I think this eclipse is going to answer a lot of questions for us. What species are affected by it exactly?
All right. Here's a question from Kazam. What is the best way to ensure seeing shadow bands during totality? I am planning to find a place with a smooth and pale pavement. What do you suggest?
That's a good question.
I did not. I'm trying to remember. Last time, I guess for the 2017 eclipse, there was enough totality. Like I did have enough time to look around and notice like the 360-degree like sunset kind of twilight colors, and you could definitely notice as it got darker that like your shadow was disappearing, but I don't remember trying to like take pictures of it or study it too closely. I guess I was just like I was looking at the sky, to be honest.
Wow.
Yeah, same here. I was just
I,
mesmerized by it.
but I'm willing to bet that there's a Reddit thread about this.
All right, well, because that
Yeah.
may have stumped the panel, which doesn't happen that often. Um, Here's an interesting question from Paula. So she says she was planning on attending the events at McGill to see the eclipse, but her question is, given that this is downtown, will there be a disadvantage to being there in terms of light pollution?
That's an interesting question. So I don't know. My impression is that most of the city of Montreal's lights are on timers. At least those are the
Yeah.
ones in parks near my house, are on timers. So I would assume that they will stay off. Now, a lot of the office buildings and stuff, they seem to have their lights on all night long, for better or for worse. But yeah, I don't know. I mean, I guess in a dream scenario, I mean, I would want to be in like the Kalahari Desert or something like that, right? Wouldn't it? Like that'd be a good place to be, where it's like actually really dark. But I mean, I think if you like work downtown, and then you may as well come just stay downtown for the eclipse. You know, if you can take the day off and go to like Mont Mégantic or someplace deeper in the path of totality, then by all means do it. But yeah, I guess I wasn't super worried about the light pollution. I don't know. Andrew, do you have thoughts on this?
Yeah, I mean, I think you're right. I think you're onto something in terms of the timers. And let's just face it, the length of time of totality is not going to be that long. What is its predicted downtown, Nicholas? Do you know the length of totality and time?
Like 30 seconds, I think.
So that's why I said I don't think that's going to give enough time for like even those with the photo sensors to really kick in that much. I think for me, there's two things. It's a trade-off. One is that you're going to have a lot of buildings around you, so you may not see have that experience of watching the shadow race across the landscape towards you because of in the urban environment you're in. So you may lack that experience. But what may what override that is the fact literally that you're going to be with thousands and thousands of people. And I can't tell you, I was on the beach in South Carolina with over 30,000 people around me. And it was literally like a rock concert. People were hooting, hollering, and it was like, we were jamming to some amazing rock group, but and everybody's staring inside. It's unlike anything else. So to experience it with a large crowd, it's very exhilarating. It's very energizing, and you'll never forget it. So I think that experience overrides some of these other more subtle effects.
Okay, so let me try. I think I get probably three more questions in. So, question from Dag: should we still be wearing their glasses when we see the Bailey's beads and the diamond ring?
Yes, because at that point,
Yeah.
you're still seeing that's sunlight that's just creeping through the valleys on the moon. So as long as you're seeing the disk of the sun even a little bit, it's best to keep the glasses on. Again, as long as you can see the Bailey's beads through the glasses, then that means you should have the glasses on. When everything appears completely dark through the glasses and you're looking at the sun and you don't see anything, then you take the glasses off.
Okay. Here's one that came in from Heidi. She wants to know, what about people who are, I guess, don't have good eyesight or are virtually blind without regular eyeglasses? What are their options? Prescription protective wear? Yeah.
Well, you can put if you wear glasses, like this, you can put these in front, hold them in front and watch that way. You would just hold the glasses in front of your prescription. That's what I would say.
Okay. And here's one more. This is a very niche question. Andrew, you have a background at Mac campus, so maybe you can take this one from Carol. She's asking about horses that are grazing outside during the eclipse. Are they at risk or should they be put into their stables?
Wow, that isn't I wouldn't know, but okay, I'm just gonna look at
There's
it
a
more
Reddit
broadly
thread,
in
I'm sure.
livestock. I could just say in terms of farm animals, the only thing I've heard is that cows that are out in the pasture have been noted to start their journey back to the stables during totality, because of course they go out and graze in the pastures during the daytime, and when the skies get dark, they're conditioned to start returning back to the stables. So I don't know, perhaps the same thing with the horses as well. They'll, if they have that, they've learned that behavior, that they come back, you might start seeing the horses start returning back to the barn during totality.
Great. All right. Well, listen, I know we're just about out of time. I know a couple of our panelists have a hard stop at 5 to the hour. So maybe we should leave things here and wrap it up for the day. Before we bring the webcast to a close, I'd like to remind everyone that this video will be available at this very same link soon after recording in. So feel free to share with others who may not have been able to tune in live, or in my case, I'm definitely going to go back as a reference because I didn't catch everything, but some really great advice here. Of course, I'd like to extend my deep gratitude to our two guests, Professors Nicolas Cowan of the Trottier Space Institute at McGill and Andrew Fazekas, the Night Sky Guy, for joining me today and providing such great insight and practical advice about next week's solar eclipse. To our audience, you can find out more information about McGill's eclipse activities on our university's website, mcgill.ca. And please continue to stay tuned to your McGill email and social media feeds over the coming weeks as we continue to share news about exciting online and in-person programming. Until then, please be well and do enjoy next week's eclipse. Thank you.